It's been on Andronic's calendar for like a year. He's like, one day, it's happening. Reminder on my phone. Chi-squared analysis coming up. All right. So, let's talk about chi-squared analysis. What I want to do is similar to what I did with chromatography. I want to talk about purpose, and then I'm going to talk about process, and then we'll do some practice. Okay? So let's split this up into thirds. All right. Let's start with purpose. Okay, so the purpose of a chi-squared test can be summed up as determining if there is statistically significant differences between two data sets. Statistically significant differences between two data sets. So it's a mathematical process of determining if there is actual differences between two data sets. And in particular, the two data sets that we are comparing is a data set that contains our observed values and our expected values. So, in an experiment, you have values that you observe, and you are comparing if those values are statistically different from expected values. Those are the two data sets you're comparing. All right. Now this in biology can be used for a whole bunch of things. But some of those uses can be in genetics. We're going to get some practice with looking at crosses, monohybrid and dihybrid crosses, to see if the observed phenotypic ratios of those crosses are statistically different from what we expected from our Punnett square calculations. We can use this in the context of studying natural selection. When we are looking at two different populations, actually, for natural selection, we can look at, for a particular population, over time, if a selective pressure is impacting that population, if there are differences in a particular trait over time, we can use a chi-square test to determine if those differences are significant, which would suggest evolution is occurring. All right. And third, we can use this in ecology, particularly in looking at the quantitative values that we're measuring in an ecosystem to see if they are statistically different from what we'd expect for those values, which can help us in studying things that might be affecting the ecosystem. All right. Now there's a couple of things that we use when we're carrying out a chi-square test. So we're going to get to the process. Okay. So the process here is we start with two different hypotheses. Okay, those two different hypotheses, you have something called H naught, which is also referred to as your null hypothesis. And then you have H1, or it's also sometimes written HA. That is your alternative hypothesis. So, the process of a chi-square analysis test is you are testing to see which of these hypotheses is supported. The null hypothesis is that differences between observed and expected values. Sorry, I got a little crammed up here, are not significant. The differences between observed and expected values are not significant. The alternative hypothesis is that those differences are significant. And therefore are not due to just random chance, but suggest that something is affecting your observed values. So notice that your null hypothesis, it assumes that there are differences between your observed and expected values. In reality, that's always the case. But it's determining whether or not those are just random differences or if they're significant because something else is going on. All right. So again, the process is for whatever you are studying, figuring out what are your observed values, and then determining what are your expected values, and testing which of these hypotheses is supported. Now, how do you actually do that? Well, so that is done through the chi-squared analysis test. Chi-square is represented with this symbol, which is your chi-squared value. And you calculate a chi-squared value by taking the sum, which we symbolize with sigma, of this calculation for every observed and expected value. So the O is representing an observed value, and you're subtracting for that particular value what was your expected, squaring that difference and dividing it by the expected value. You do that for each one of your observed values, add them up, and that gives you your chi-squared value. All right. Now, what we take this chi-square value to do is take this chi-square value and we compare it to something called a critical value. Critical value. Now, a critical value is a value that is based off of two things. It's based off something called degrees of freedom and a p-value, which most of the time is 0.05. Now, we're not going to get into the statistical theory behind degrees of freedom and p-value, but I'm going to show you how you can find this critical value on the chi-squared table. It's okay if this feels very abstract right now. It'll help when we do a practice problem. You'll see the use. Okay, so you got chi-squared value, which is calculated using this formula that you're comparing to a critical value, which is based off of degrees of freedom and a p-value. Now, last thing about degrees of freedom. Degree of freedom we're going to determine by taking the number of possible outcomes and subtracting 1.